Welcome to this channel. Today I want us to discuss a topic. The topic is called limits, and this is a question we want to solve. So when they give you something like this to solve, how do you start? Okay, the first thing you're going to do is this. You pick your x. Now you will replace this x with 9. Okay, let's do it. So I'm going to write limit x approaches 9, and that will give me 3 minus square root. Now remember, I'm replacing x with what? 9. Then over, again, I'm replacing x with what? 9. Then minus 9. So let's solve this together. So you will notice that the numerator, now root 9 is 3, so 3 minus 3 will give you 0. Numbers now give you 0. Now, when you see something like this, 0 over 0, in engineering, we call it indeterminate. Indeterminate. What we mean by indeterminate is that this thing cannot be done right now. So we need to go through some other steps to get the answer out. So what are we going to do instead? I'm going to explain to you now. So what exactly am I saying? Let me explain. Now, for me to solve this, I'll go back to the question. So, but this time around, I'm going to use a concept. It's called rationalization. Rationalization. It's a familiar term in further maths, but I'm going to still explain. So we have limit. X approaches what? 9. So we have 3, right? Let me use red ink. We have 3 minus root x over x minus 9. So what are we going to do with this? You see, at this point in time, what we're going to do is that this very expression, the one on top, I'm going to kind of change it. Now, what do I mean by that? Let me explain. Now, this expression on top, I'm going to find its own conjugate. And the conjugate of this one on top is this. The minus here will become a plus. Do you understand? Then the 3 will remain where it is, and root x will remain where it is. They won't change, okay? So when I'm done with this, then I will divide by the same thing. So I'm dividing by 3 plus root x. Do you understand? So what I did was this, I found conjugate of this one on top. So this minus became a plus, and this remain the same. Now, when you now get to this level, you cannot begin to multiply, okay? So let's multiply. But I'm not going to multiply this, the normal way. I will tell you why. Because there is a shortcut. And I will show you the shortcut now. You see, in mathematics, it is very true that you might come across something like this. If you see something like this, you see a difference. And you see a sum. A difference and a sum. You can just take the first part square minus second part square. Now this is a rule in maths. It's called difference of two squares. So if I see a difference and a sum and they're multiplied, you can just write it in a short way. A square minus b squared. So what do you observe? You will notice that this is a sum and this is a difference and this is a sum. And they look just like this. Do you see it? It's as if I'm saying this is my A, this is my B, this is my A, this is my B. So A minus B times A plus B. Can you see it? A minus B times A plus B is A square minus B square. So instead of me saying multiplying it out, I can just use this. A minus B times A plus B is what? A square minus B square. So let me do that, okay? So that means for the top, I'm seeing a square, which is 3b square, minus b square, which is root x square. Okay, I think we're done with that one. So I can write my limits now because I have to write it. It's compulsory. Then what about the denominator? We can leave it that way. It's not a problem. X minus 9. Do you understand? X minus 9 times 3 plus root x. So let's look at the top, okay? So what will the top give us? Let me send the ink. So I'm going to have, so this will be 9 minus. Now, root x square, this square can cancel the root. So I have 9 minus x over x minus 9. Then this is 3 plus root x, okay? Meanwhile, my limit is still here. Don't forget your limits. Don't forget your limit, okay? Now, how do I do this? Let me turn the page because there's something interesting to do here. So I have limit already. X approaches what? 9. So right now I'm seeing this. So let me write it here. I'm seeing 9 minus x. I'm seeing x minus 9. I'm also seeing 3 plus root x. Let me confirm what I wrote. I think I'm right. So with this, we can continue, okay? But there's something I want to look at, please. If you observe, you will notice that these two guys look alike. Let me not tell you what to do. If I'm you, this one on top, just write minus, then open the bracket, then write this inside. I mean, this one here, turn it to this denominator. Now, what you are doing may sound strange, but let me explain. Now, if you were to open this bracket again, see what you get. Minus times x minus x. Again, minus times x minus x. The minus times minus 9 plus 9. You can see that it's the same. So basically, if they look alike, just write minus, open a box, then turn it to the denominator. Then if you want to confirm, open the bracket again, the way I did my own. Minus times x, minus times minus 9 plus 9. So it's the same. So I think I can go down now. Then you have this, and you have 3 plus what? Root x. And remember, your limit is always here. Your limit is always here. So right now, I can cancel these two guys. So I'm left with what? Minus 1 on top. Then I have 3 plus what? Root x. And here, my limit is still there. X approaches 9. So here, I will change my x to what? To 9, as usual. So that will give me limits. X approaches 9. So we have minus 1 over 3 plus root 9, because x is changing to 9, okay? So what's root 9? 3. So the answer is minus 1 over 3 plus 3. So the answer is my 1 over 6, and that's all.